Recording. Okay, so we're going to cover chapter 4, and this is really one of the coolest chapters, I think, of Cisco 3. We're talking about EtherChannel and HSRP, two really cool solutions. All the other things are routing protocols, not as fun, I don't think. I think we're hitting the fun stuff right now. I think chapter 4 is the best, coolest chapter of Cisco 3. Right? So let's dive right into it. Let's talk about what EtherChannel is and everything else. So what EtherChannel is you basically build a trunk with 2 Ethernet connections between your switches. This does multiple things. It builds up some redundancy. So if one goes down, the other one can carry the traffic. It also increases your bandwidth by double, right? So it actually balance loads. So if you see these EtherChannel ports right here, EtherChannel is these 2 Ethernet connections going between this switch and this other switch here. And they are virtually, what you do is you create a virtual port or a virtual interface for both of those. And you wrap them up into one, and you actually call it something else. You call it a port channel. And so you create this port channel, which includes both Ethernet ports, and now you've just doubled your speeds. And it's so cool with EtherChannel is that you can use up to 4 Ethernet. Oh no, you can do 8. Yeah, it's 8. You can use up to 8 Ethernet connections to create this EtherChannel, which means you can increase by 8-fold your bandwidth between switches. And so that's pretty cool, right? And so you can take those 8 switches. Let's see here. Yeah, here we go. So this is what it looks like. So here's your switch. You can use up to 8 ports. So these 8 ports can be wrapped up. That's your channel group, and bind them together as one, and they're a logical port. So it's called a port channel, and they all work as if they're one Ethernet connection, right? But what happens between those 8 is it balance loads. It'll send an 1/8 of each of the data between all 8 of those, and they'll all be shipped at the same time and travel down that path. And so you've just increased your bandwidth by 8-fold. This is actually something very similar to what they do with DSL. So if you have DSL connection, like through CenturyLink or something like that, all they do is they take like 128 dial-up connections, wrap them up, and that's DSL. That's all it is they take all these dial-up connections, dial up, you know, from back in the 80s and 90s, and bunch of them together, and that's how you get DSL. Now it's kind of a little different technology, but the concept is basically the same. So anyway, this is what EtherChannel is, and it's a really cool feature. Now STP, the problem is, if we go back to this earlier slide, as we learned in our previous chapter with STP, if you have some redundant lines, STP automatically shuts down one of those lines, right? So here, if you look at this, if you don't have EtherChannel, if you just line up 2 Ether cables and connect them between this switch and this switch, well, STP, which is turned on by default, is going to look at that and go like, oh, that's redundant. I'm going to block that, because that's going to avoid, we're going to create this broadcast storm and everything else, and it's going to cause some problems. So it automatically will block one of those connections. Well, what EtherChannel does, it bypasses that. And when you actually group them together, it looks like it's just one interface for STP. So STP doesn't know any different. STP thinks these 8 are actually one connection, and so it doesn't end up blocking it. Because otherwise, 7 of these 8 would be blocked, right? And so we don't want that. We want them to all work as one. All right, so this is EtherChannel, really kind of cool, right? The thing that manages EtherChannel is, let me see if I can find the right slide here. Is something called PAG-P, right? Port Aggregation Protocol. It is the protocol that manages this EtherChannel. I think we got someone else joining us here. So this PAG-P helps manage EtherChannel. It helps that if, let's say, so you have these two Ethernet connections grouped as one EtherChannel together, right? One of them gets disconnected or goes bad or something like that. It's PAG-P that regroups it together and goes, okay, one's down, that's okay. We'll just compensate with the other one that's plugged in and you should be good to go. Yeah, you lose your bandwidth, but you don't go down and you're still connected, right? So that's what PAG-P does. Now, PAG-P, just so you know, it is a Cisco proprietary protocol. There is another protocol that we're going to talk about later, which is not Cisco proprietary, called LACP. LACP is the abbreviation there. And we'll get that here into the next slides or so. So PAG-P is Cisco proprietary, which means it only works on Cisco devices. So if one of the switches is a Cisco device and the other one is an HP device, you can't use PAG-P to manage your EtherChannel, right? So you have to use something else. So this only works with Cisco devices. Now, for PAG-P to work, there are these different modes for them to work. If it is on, if the PAG-P modes are on, then what that means is that these cable connections is EtherChannel without any type of management to it. It's called a static connection, and it will load balance and work as EtherChannel. However, if one line goes down, it doesn't know how to manage and compensate for that. So PAG-P kind of adds this greater intelligence to EtherChannel. And so what you have to do is on either side of the switch, you set it up as auto and desirable is the term that you use. And so that's the actual mode, and that's a command that we're going to be using to actually turn on PAG-P mode so that it can help manage this EtherChannel. All righty. So that's what PAG-P, let me see if I'm missing anything on here. PAG-P sends signals to kind of help manage it back and forth every 30 seconds. It checks for consistency, if anything's failed or added, or if there's been another connection made. It manages the speed and the load balancing. And anyway, you can have something as auto and desirable. So one side's auto, one side's desirable. It all works. One side could be on, one side could be desirable. It all kind of works too. All right. Yeah, let's go on to LACP, L-A-C-P. Just the next slide here. Link Aggregated Control Protocol, right? So this you would use, I prefer to use this all the time because I prefer open standards that work on all switches and routers. Does the exact same thing that PAG-P does, though it works better obviously with mixed environment. Well, it's the only thing that will work with mixed environments, right? So if switch 1 is a Cisco, switch 2 is some other brand vendor switch, this is the protocol that you would use. In the lab, you're going to set up both between 3 switches. One connection between a switch, you're going to be PAG-P. The other one is LACP. And so you're going to be setting up both in the lab. And I'll demonstrate how to do that. They're both very similar. Just some of the terminology is different. For instance, the modes, instead of desirable and auto, they have active and passive. But active means the same thing as auto. Passive means the same thing as desirable. Right? So when we go back here to this slide, remember how they auto, desirable? Yep. They just use different words, active and passive. Means the same thing, right? Multi-vendor. All right. That's it. That's the EtherChannel, guys. And then I'll do a demonstration on it, on how to set it up and the commands and what we need to do, and kind of walk you through some of the lab. But that's it. I think that's the explanation of it, of how it works, right? So let's talk about First hop redundancy protocols here. HSRP. This is the one where I screwed up with, where you don't really have a lab, but go back and review it, right? So that's this right here. All right, one of the problems, this is for routers. And one of the problems in building redundancy with routers, so if you want to build 2 routers on your way out to be your gateway or something like that, there could be a problem, right? Because PC1 can only take 1 gateway. When you go in and you set up and configure your PC or your end device, you don't put in 2 gateways. You only put in 1 gateway. So even if you have 2 routers here, if router 1 goes down and that's the gateway for PC1, well, PC1 can't get out. What you would have to do is go, oh, you would have to know that router 1 is down, right? And if this is just an average user, you know, the secretary or whatever that's using her computer, she doesn't know. She just knows she can't get to the internet, right? So what you would have to do is you'd have to go to router 2 and change the default gateway in PC1 to router 2, right? And the average user would have to know to do that, or they would call you guys up to come and do that. But that is unnecessary. You don't have to do that, right? And this is where HSRP comes in. What HSRP does is it allows you to build inside each of your routers this thing called a virtual router. This is not a really good picture of it because it's not, let's see, there's a better, yeah. Let me see if I can find a better, yeah, here we go. I like this picture better to help explain it. So what happens is you have these 3 PCs at the bottom all connected to a switch, right? And you have 2 routers that are going through, and this router has this IP address and this other router. Here, let's see, around this. So this router has this IP address, right? This router has this IP address, 2 different gateways, right? But what you can do is you can build what's like a virtual route within your routers. And in router 1 and router 2 that have the same IP address. So what you do is you tie this virtualized route, virtualized port and IP address onto router 1 and to router 2 using this IP address right here. So basically, it's like it lays on top of it. So even though router 1 has this IP address, .2, you can overlay this virtual IP address, 10.1, over here. So that router 1 looks like it is 10.1, even though it's really 10.2. And router 2 over here, even though it's .3, is running the same virtual configuration, and it has 10.1 as well. So basically, you have kind of these kind of mock IP addresses on both of these routers, and they have the same IP address, kind of these fake virtual IP addresses on both of these routers. So what happens is now these PCs down here at the bottom, right? You put in the virtual IP address 172.16.10.1 as the gateway. Now, if this pathway goes out, that's okay. It will reroute to here, the .3, and you don't have to change anything on the PCs at all, because the PCs will think that this route right here is this virtual IP address that we've created for it, right? And so that is what HSRP is. Pretty cool technology, right? It's basically having the same IP address on the same network, right? Normally, if you put the same IP address on the same network, you have some problems and you have some conflict, and it causes chaos on your network. This is a way around that. That basically we are putting one IP address here, this IP address, on top of this IP address and this IP address. So that all the devices here, we just have to put in one gateway address and they know their way out. Oh, okay. We'll go this way, we'll go this way, we'll go this way, this way. It doesn't matter because it all runs off this same virtual IP address. Pretty cool, right? Okay. So let's jump into the lab and the demonstration. I'm first going to show you this HSRP because this is the lab that I screwed up on, right? That I didn't assign you guys. That's optional, right? But will be on the final. So here's the lab. Whoops, this is not the lab. Here's the lab. Okay. This is the configuration that you'll be working on. This is the optional lab, right? Though I highly recommend you at least review it or try it out, or at least you don't have to go through the whole thing. Just build the HSRP aspect to it. And what you're going to do is you're going to set up these routers, router 1 and router 3, with that virtual IP address, that HSRP configuration, right? You first set it up with, if you look here, they have this IP address and this IP address. And look at over here. At the PCs, you have different gateways. And there's going to be a point in the lab where you change the IP address of these gateways to what the virtual IP address is that you set up. So if you go through here, you do have to set up some VLANs. You know, you can skip all the password stuff since this is kind of an optional lab. You can do a trace route, yeah. So you can kind of skip all of this stuff and come right here. This is the command to set it up, right? So what we're doing is we're setting up the virtual IP address to this using the standby command. So what's going to happen in router 1 and router 3, you go into the interface, that's the gateway interface, and you issue the command standby version 2. There's multiple versions of standby. We're going to use the latest one, which is version 2. You create this virtual IP address for that. Remember, router 1 had a different IP address, right? I think it was 1.1 or something like that. Let's look. Yeah, router was 1.1 and the gateway was 1.1, right? But we're going to lay this as the virtual gateway address, okay? Then you have to set a priority to it and do this preempt command. Then you're done. HSRP is done. You do need to go to router 3 and set up the same thing, though. However, you don't need to put the priority level or the preempt, right? The reason for the priority and the preempt is just to designate which one is the priority, is the lead, right? Which is the default route out, and if that one goes down, then the other one goes, right? You have like the first string and the second string router, and that's all you're designating with this priority and this preempt here, right? And so you're setting this up as the priority one. And so this one is the backup one. But see, you're going to set up the same virtual IP address with the standby command on router 3, and then boom, the PCs, they can't even tell. They think there's only one gateway IP address, right? Only one gateway router. And that's all the user knows. So it's really not too hard to set up. This is it right here. And then they have you go through and you can verify the standby, shows you the verify. And then they want you to go back and start to ping and to actually change the gateway addresses on the PCs. Okay? And then that's pretty much it for this lab. Not too bad, right? So please do go through this, even though I'm not grading it, or you can substitute this one. If you do want to go this in depth, I will substitute that one for this packet tracer. Just submit it with this packet tracer. And that's fine, okay? Now, let's get to the EtherChannel Lab, which is this one here. Notice there's PAG-P right here on the top, connecting switch 1 and 3, and they're using LACP, LACP here, connecting switch 1 and 2 and 3, right? Notice next to it, it shows you an option P01. Well, that's our virtual port. That's our port that's wrapping up, that's our port channel that's wrapping up these two connections. Connection Fast Ethernet port 4 and 3 together to be one. This is our virtual Ether channel connection, is the P01. And notice this is P02, P03, right? So let's go ahead and set this up. Now, as part of this lab, you are going to have to set up some VLANs and VLAN 10. You should already know how to do that. You guys are in Cisco 3. You're pros at creating VLANs and everything else. So the first thing we want to do before we create our trunks, right? You set up your VLANs, and you can set up your VLANs afterwards even if you want. Before you set up your VLANs, or your trunk, because these are going to be your trunk. Yeah, I know. Hopefully you guys can still hear me and see me. Before you set up the trunk, you set up your Ether channel first. This is kind of the key. And then you set up your trunk, you know, where you do your switch port mode access, your switch port mode trunk. You do that after you set up the Ether channel. So that's the only kind of guide. And then everything else is the same. And it's not too bad. So let's go down here. So the first thing we're going to do is I'm going to do this interface, and we're going to create this channel group 1, right? So it's a group channel. We're basically combining the Fast Ethernet 3 and 4, and we're going to create it as one channel 1. And that's what we're calling this, channel 1. 1 is kind of arbitrary. It's whatever you do. It's our first one that we're creating. And so that's what we're doing. And then we're putting it in mode desirable. And then we go to switch 3, and we do the same thing. We do this. And you guys are familiar with the range, right? Interface range. Hopefully you guys are. It's cool. I don't remember what you guys learned in Cisco 2 or not. But range allows you to basically change multiple interfaces all at once, right? You can, like, if you need to shut down, like, all the ports that you're not using, you can just put the range there and then put no shutdown for one of those, and then they're all down. Or you put shutdown and it shuts them down. Or put no shutdown to open them up, and it does all of them all at once. So it's kind of cool. So same thing here. You can group them together. And it just works really good. So let me actually open up my terminal here so you guys can see. All right, I already set up my VLANs and did all the prerequisites and everything for it. So I'm going to show you how to set up that PAG-P. All right, so first thing, we need to go to global configuration. And then I'm going to, as I showed you in the lab there, we're going to open up these range for Fast Ethernet. And my switch, it's a 203-4. So I'm going to do port 3 and 4. And you go into, so if you haven't done this before, then you're in this range, meaning I'm in both at the same time. So now anything I type applies to both. And so then we're going to do the channel group 1, mode desirable. Like that. You get this notification that it created a new port channel. And we'll look and verify this, that we have this port channel interface, port channel 1. It's abbreviated as PO1, kind of like your local, your logical interfaces that we do on routers sometimes as well, okay? And then we want to do no shut, because it's just like any other interface or port. We want to open that up as well, right? And that's it. I'm going to end there, go up, go to the top here. I'm going to go to switch 2. I'm going to do the same thing because you have to do the same thing on both ends, right? So I have done this connection here, switch 1, 3, and 4. And now I only have 2 switches. So I kind of, I did 3 and 4 to switch 2, and I did 1 and 2 to switch 2. So that's why it's a little weird. But I'm working on this connection right here. So pretend I'm in switch 3, but really I'm in switch 2. Because I only have 2 switches. All right, so I'm on switch 2, and I'm setting this up. So same thing, I'm gonna go global configuration mode. I go into interface range, and we're gonna do fast, and this one is 3-4, so we can go into both, right? And then we'll do the channel group. We want to group these together. It needs to be 1. The big thing is this has to be 1, the same number that it was on the other switch. That's really important. Okay, and then we want this mode desirable. You can have desirable on both sides, or you can have auto. There we go. Created the port. Now we're going to make sure it's open. No shut. And we're good. Right, so now let's verify this a little bit and see what this looks like. So this could be part of your lab report, right? You need to display some screenshots so that I can see that you have your Ethernet port set up correctly, right? So you can just, you can do show run if you want, and go down to where the ports are that you configured. And look, if I go up here, look at that. It says channel port 1 on, fast Ethernet 3, fast Ethernet 4. I have the channel group 1, desirable. And if we go down at the bottom, oh, maybe it's at the top. Oh, right here. Look at this. Ethernet port channel 1. This port channel 1 is this and this. This is our Ether channel. This is how we configure everything now. This is where we're going to configure our trunk. We're not going to go and configure our trunk here anymore because we created this new virtual port, which is a combination of these 2. And this is where we're going to build our trunk. Okay? All right. So let's see if we can, yeah, let me show you this. You can also do show EtherChannel summary. And you can look here. See, I have port P01. It's set up as PAG-P. And the ports that it includes is 3 and 4, right? I can have up to 8 if I want, right? If I had enough Ethernet cable here, I can have 8 ports, all be grouped into this one virtual port channel, right? And so, like I said, now we're going to go into this port channel to set up our trunk. And you set up the trunk just like you always have before, except we're going to use P01 as the port that we're going to go into as our trunk, right? So let's go ahead and do this. I know I'm on switch 2, but we have to do this on both sides anyway. So since I'm already in 2, we'll stick with 2. So I'm going to go into global configuration mode. And I'm going to go to interface port channel 1, because that's what we set up, right? And then I think I do have to do the switch trunk encapsulation. Yep. .1Q. Then the switch port mode. Yeah, you don't have to type port. You don't want to. Mode trunk. And then switch port mode, or switch port. Sorry. Need to get back into it. Need to turn that off. Give me a second here. It's freezing. I probably hit a bunch of things. I think I can just do that. Yep, to get you into the interface. That's a short way to get into the interface. So then we have to do the switch. So we did switch port mode trunk, right? So now we're going to do switch port trunk native VLAN 99 is where we're going to put it on, right? And the instructions tell you before to create that VLAN 99 as your trunk. So if I do that, you're good to go. All right, and then you can do, here we go, do show run. Build this up a little bit, show you what we did here. Now, look at on this virtual port. You can see that this virtual port is our trunk that we're using, right? It is our Ethernet trunk that is managed by PAGP, right? How do we know that? We can do, let me go here. I don't want to end here. We want to show EtherChannel summary. It's this right here. It's those two right there. It's all set up and ready to go, right? So you do need to go back and do that on the other side, right? So I'm in switch 1, I'm in the other switch. So I'm going to go back there. Global configuration mode, PO1, right? Because we already created it. I have to do my switch trunk cap.1q and do my switch mode trunk, switch port mode trunk, and switch trunk native VLAN 99 so that we know that the VLAN 99 is our trunk. And there you go. All right, let's look at our interface. So again, different way to look at the, oops, if I can type. Let's take a look at this. Kind of a short way to look at it. You can do show run, just interface PO1 if you want. If you don't want to show all of show run, you can just show that interface. And right there, you can see on switch 1, I have the same configuration that I have on switch 2 up here. Oh, it shut down though. Look at that. It shut down. I have to go back and fix that. Look, I just noticed that. Ah, see, that's tricky. So you guys got to make sure you watch for that. I got to go back and get on there. Let me fix that real quick. Interface PO1, right? No shut. There we go. Now it should be good. Yeah, see? Now it's coming up. Should be up. Right? Let's see. Show run interface PO1. There we go. Now it's open. Okay. That's how you do it, guys. All right. So that is PAGP. Okay. Now, that's just half of it, right? We just did this connection here. I mean, it kind of curves around because I have a weird setup, right? I have these kind of curving around going here like that because I don't have switch 3 on my thing, but I'm just kind of mimicking it, right? So now we're going to do this LAC-P, this connection between switch 1 and switch 2, done almost the same way, guys, just one word difference, right? Remember, because instead of desirable, we use another term, right? So let's go down and look at that. Get rid of here. All right. So I'm going to go back to switch 1. And let's set this up. So now I'm going to go into, I'm going to go to interface 1 and 2. 1 and 2, right? So we did 3 and 4 as PAC P. We're going to do 1 and 2 as LAC P. So I have to go into those. So it's going to be range. One and 2. So I'm going into both of them. I'll do my switch. Oh, I probably have to do. Oh, no. Oh, we have to create our channel, right? Switch port mode trunk. Oh, I forgot. It's trunk. Cap. Dot 1, 2. Okay. Then we can do that, right? Now you're going to see, because I'm connected to the same switch with both connections, STP is going to frick out. So you'll see some connections with STP as well. So now I'm going to, so with LAC, what you're going to notice is that I'm setting the trunk first, and then I'm setting up the Ether channel. So there is, I didn't even think about that when I was going through this first. So yeah, so it's kind of in reverse mode. With the PAC P, you're setting up your channel connections first and your Ether channel first, and then the trunk. With LAC P, we're setting up the trunk first, and then we're going to be setting up the channel group and grouping these together. Okay. So I need to finish this trunk. I just put it into trunk mode, right? And now I need to assign it to our VLAN 99, right? Okay, now, see, this is where STP is freaking out right now. STP, that's okay, it's normal, it's okay, and it's because I have two connections going into the same switch, right? Spanning tree is going to block one of them, but that's okay for this demonstration. It's fine. All right, so we need to do channel group. Now, this is going to be channel group 2, right? This was channel group 1. This is going to be channel group 2, PO2, right? Because this has a PO1, this is going to be PO2, okay? So make sure that this is 2, and you're going to have to do this on both sides, right? Mode, and it's active, right? That's where the terminology is different. And you can see here that it created our port channel interface 2. So now we can look at PO2. Now, I do need to do no shut to do that. But then I can end, and we can do or show Ether channel summary. And look at that. So we have interface PO1, which is PAG P, right here. PO1, which is PAG P, that's this one. Then we have PO2, which is our LAC P connection right there, right? Now, we need to go to the other switch, switch 2, and do the same thing, right? It's freaking out a little bit here. All right, calm down. All right, give me a chance here. Okay, so we're going to go into interface, range, fast Ethernet. This switch one is like this. 1 and 2, right? So I'm in the range. Then we're going to set up the trunk. Oh, I keep forgetting. Doing the encapsulation. Trunk, encap, .1Q. And we'll do the trunk, right? Then I'm going to assign it to switch trunk. Native VLAN 99. There we go. And now we're going to create the Ether channel, right? By doing channel, this will create the PO2. And this has to be the same on both sides. 2 mode passive again. Should do it. Yep. Did the command right. So this created our port channel interface mode 2. There's the command that I actually used. Because I know it got away, but that created our port channel, right? So we can verify some of this. If we end here, clear up to the top. I could do my show run is probably the easiest. So this is what I should see. Here are my 2 virtual ports, my Ether channel ports, port 1 and port 2, right? These are my 2 virtual ports that I'm Ether channeling. Cool. These have twice the bandwidth. Isn't that kind of cool? I think it's way cool. So now you're communicating between those 2. So this is my PO1, my PO2, right there. Just set that up. All right. And there it is. We have just set up Ether channel. And I think it's pretty cool. I love Ether channel. There's something you can do on the WAN side as well that you'll learn about a little bit later in Cisco 4, which you can do the same thing on the WAN side out to your ISP and things like that, right? Between routers, that is similar. All right, guys, this is all I have for you. Let me stop the recording